everyone. I'm Kiera, Brodsky Chase. My pronouns are they, them. I work for an organization called Connected. At Connected, we make potential exponential by partnering with school districts across the nation to improve outcomes for students so that everyone graduates prepared for college, career, and life. Why is it? Sounds like it's echoing. I'm excited and a little nervous to be up here today. I'm going to spend my 5 minutes talking about the connections between the creative endeavors of music making and mathematics. We can think of this as sonic representations. But first, a little about me and my history with music. This is me at about age 4, really owning that triangle. In 9th grade, I discovered Bob Marley and Pearl Jam. That was a fun phase. And as Brian said, I most recently was spotted at the Olympia Farmers Market where my band made their debut. It was my goal for 2023 to perform, and I made that happen. Thank you. But enough about my musical notoriety. I'd like to start by talking a little bit about sonification of graphical representations. So for this example, let's assume that the x-axis is time, and that the y-axis is all of the white notes on a piano. And the origin will be, let's say, middle C. So this might sound or look a little like this. Do, re, mi, fa, sol, la, ti, do. And it's a linear. And a sine or a cosine might look and sound something like this. Ooh. Speaking of waveforms, sound is actually in waves, and there's frequencies. So for higher pitches, there's higher frequencies, and for lower pitches, there's lower frequencies. So the note, for example, like la, might have a frequency of 440, and then an octave higher. La, la, might have a frequency of 880, which is exactly double. It's so amazing and fun. But moving on from sound, let's talk a little bit about rhythm and beats. So once it gets going, in songs there's a time signature, and that describes the amount of counts in a measure. So in 4/4 time, this is a whole note. So it's 1, 2, 3, 4, 1, 2, 3, 4, which is equivalent to 2 half notes. 1, 2, 3, 4, 1, 2, 3, 4, which is equivalent to 4 quarter notes. 1, 2, 3, 4, 1, 2, 3, 4. And you guessed it, it's equivalent to 8 eighth notes. 1, 2, 3, 4, 1, 2. I'm not gonna keep going with that. You get the picture, 16, it's too fast. And this is sort of like a traditional rhythm where the beats are kind of divisible, but there are these things called polyrhythms where there's 2 things happening at the same time that are not divisible. So in this one, you could think of it as the right and the left are doing different things. I'm going to demonstrate. So both my fingers are going to snap, and then it's right, left, right. This is very reggaeton, you know? Murder, she wrote. Murder, she wrote. Oh, I kind of messed that one up. All right, so we've come to the audience participation section of my talk. Put your drinks down, please. All right, we're going to split the room. This is not very even, unfortunately. Let's say I'm not allowed to go past this panel, but the edge of the stage over there, you're going to clap on every one, all right? So it's on the 5th count, but really you're doing it on the 1. And then this side of the room, we'll get to what you're going to do in a minute. We're going to do a 5-3 polyrhythm. All right, you with me? Over here. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Nice. 1, 2, 3, 4, 5. All right, keep that going. Keep that going. All right, this side over here. 1, 2. You're going to clap on every 3rd one, starting with that 1, and then the 4, and then the 3. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Yes! That was amazing! And it's in a line, too. Isn't that cool? Thank you so much. That's my time. Give yourselves a round of applause. It's magic in here. Think of all the magic we can make out there for our students.
Thank you, Kiera. Awesome. That was fun.